I will be talking about the GENESIS mission as ESA and IAG cooperation for mission success. I'd like to take the chance to provide a recommendation by ESA, so the correct writing of the name GENESIS is like this with small letters. Okay, so I just have to move, yes. So GENESIS is an ESA mission for improving the terrestrial reference frame. So it's a mission connecting two GNSS receivers, satellite laser ranging, DORIS, and the VLBI transmitter on a satellite, plus there will be an ultra-stable oscillator on board. The launch is planned for 2028 with at least 2 years lifetime, and the GENESIS will fly on a circular orbit at an altitude of about 6,000 kilometers. Right now, the specification is that it will have a 95 degrees inclination, but actually there are some discussions going on about the inclination right now. Mass 250 to 300 kilograms, and of course, and this is distinct for the mission, there will be a very accurate onboard metrology. So the space tiles will be measured very accurately and carefully. For this GENESIS mission, the orbit of the satellite is the centerpiece of the mission. And in the best case, this GENESIS orbit is determined from all techniques in a combination. So at the observation level, normal equation level, or eventually, or perhaps product level. I will come back later to this. Okay. Let us first take a look at the bigger picture. So you probably are familiar with this chart, which was published by the National Academy of Sciences. And at the bottom, you do see the geodetic infrastructure. Here we do have our stations, for example, VLBI radio telescopes, but here we will also have the GENESIS satellite. And this is the basis for an accurate terrestrial reference frame. And the TRF is then again important for precise positions, orbit determination, etc. And if we go further up, it is the basis, for example, for accurately measuring sea level changes. So here, GENESIS plays a fundamental, very important role. So actually, GENESIS is not the first attempt for a space-time mission. There are more. Not listed here are, for example, the MINC mission or EGRIP mission. But of course, very important in that respect are the GRASP proposals to NASA, which were unfortunately not successful. There also has been an eGRASP Eratosthenes proposal by Rishabhi and Kal et al. Submitted to the ESA Earth Explorer 9 call. This proposal was highly rated, but also it has not been successful. But finally, this proposal formed the basis for a white paper on the GENESIS mission. So GENESIS collocation of geodetic techniques in space. And this white paper by the community played a very important role for getting the GENESIS mission. So you see the authors of this white paper are made up of geodetic scientists and also representatives from ESA, like, for example, here Javier Ventura Traveset, who played a very important role for getting the GENESIS mission accepted. Okay, so this paper is too fast. This paper was very important, and the GENESIS mission was finally approved at the ESA Ministerial Conference in 2022 for launch in 2028. GENESIS is managed by the ESA Navigation Directorate and is part of its Future Nav program. Also in the Future Nav program is the LEO PNT mission, so to say. In the beginning, GENESIS was supported by Belgium, France, Italy, Switzerland, Hungary, and the United Kingdom at this ministerial conference. And since recently, also Germany is supporting this mission, as we have learned at the ESA GNSS conference in Wrocław recently. A consortium led by OHB Italia is tasked with the development and building of the satellite. And right now, the final specifications for the satellite are being fixed. The project manager is Sarah Gittlund from ESA, and here she is presenting at the science workshop on February 29 this year, where many of the geodetic community took part. Okay, the ESA is setting up a GENESIS science team. This GENESIS science team consists of the GENESIS Science Exploitation Team and the GENESIS Science Management Board. The exploitation team is made up of a scientific coordinator and co-coordinator, Özgür Karatekin and Francesco Vespe, and 5 working groups, ITRF and combination of techniques, chaired by Suhe Altamimi and Florian Seitz, GNSS, chaired by Rolf Dach and Benjamin Mennel, VLBI, Rüdiger Haas, Doris Guillaume Moreau, and SLR Clément Court. And those persons are also, those working group chairs are then also in the GENESIS Science Management Board together with ESA representatives. On the other hand, in IAG, we do have a working group 111 on GENESIS, and this is a joint working group with GGOS and the IRS. The members are from the geodetic community, and of course the membership is overlapping with the membership in the working groups by ESA. So this IAG working group is an open forum for discussions. This is not always so easily possible with ESA working groups, but this IAG working group should be an open forum with regular meetings and reporting, and we do have a web page here at this address. Just this week, Monday and Tuesday, we did have a working group meeting at TU Wien. It was a hybrid meeting with an on-site component at TU Wien. We had 18 participants on site. You can see them here on this photo, and we had about 30 online participants. So we got reports by ESA and ESA working groups, and Monday afternoon we focused on technique-specific issues, and Tuesday morning then on combination aspects. And I would like to provide you with some information or news from that meeting. Okay, in terms of GNSS, it was again stressed that it is important to know the satellite phase center pattern. So when taking a look at this sketch here by Oliver Montenbroek et al., you see that the off-boreside angles from the GNSS satellite to the GENESIS satellite are rather large, 20 degrees and more. This is not the case with LEOs, where we typically use GNSS receivers on satellites. So it's very important to know the satellite phase center pattern also for larger angles here. So that is critical for the success of the mission. And of course, there has to be a calibration of the antenna on the satellite, and this calibration should be done as a joint calibration with the full satellite. This is very important. Then with DORIS, of course, there is a visibility of more beacons simultaneously with the higher GENESIS altitudes compared to LEO missions and other missions. And first tests with DGXSS were successful. With VLBI, the VLBI transmitter, this is a very new thing, and that is quite challenging, but the frequency bands are now fixed. We do get 4 bands, all wider than 200 megahertz, which is good. There are some concerns about the phase center, or perhaps those 4 bands will have different phase centers, which will then be rather challenging for the analysis of the observations. Then a PON signal for ranging is under consideration, similar to GNSS code signals. So this might be an option that such a PON signal is on one of those bands. But of course, it's only welcome if it comes for free and doesn't harm the other classical interferometric VLBI measurements. With SLR, there are concerns that the reflector, which is currently considered, is too small to be observed from all stations. And also in that respect, some discussions are still ongoing. Then an important wish by the community is that as much metadata as possible are provided by ESA. So there are requests to get a lot of metadata or all metadata needed. And of course, GENESIS is critical in the aspect that at 6,000 kilometers altitude, the radiation is rather dangerous for the instruments on board. Then on the second day, we focused on different combination scenarios, and with Hugentobler gave an interesting presentation on different levels of rigorousness. So I will not have the time to present you all levels, but as I already mentioned, orbit combination will be, or orbit determination will be critical for the mission success. And we've talked about the orbit combination at the normal equation level. And one caveat here is that you cannot simply stack initial state vectors because you can only stack it if the same force model would be used by all analysis centers. And this probably cannot be guaranteed. So that is quite tricky then. Of course, on the other hand, you could stack positions of the satellite, but then the normal equations would get rather large. So, but there are some ways to overcome that issue. For example, ways based on transformations mathematically. So that's a possible way out. And of course, at some point, an extension of the SINEX format will be needed so that orbit information is also included. Daniela, who probably is sitting in the room, is taking the lead here. And then again, one discussion point was that the orbit inclination of 95 degrees might not be optimal for the GENESIS missions, and there are still discussions going on. Good. In summary and conclusions, so the cooperation between ESA and the geodetic community is the basis for the GENESIS mission. The GENESIS mission is set up differently compared to the other missions. So GENESIS, I guess it's not always is not a very easy mission for the European Space Agency because of this. The very good thing is that GENESIS really brings a lot of momentum into the community that is very much appreciated. And so let's actively contribute to make GENESIS a success. Thank you.
Thank you, Johannes. Any questions for Johannes, either from the room or online? Yes, we do. Roland.
First of all, the comment. I'm very happy that we are now in a golden era for Geodesy, having in the very near future 2 important missions, both on gravity and geometry side. So you mentioned this nominal mission period of 2 years. Is this just a constraint regarding, let's say, maintenance of the satellite funding issues, or is it just a nominal one and the hope is that it will continue much longer? Or is it related to technical issues, radiation and this type of thing?
So as I understand it, this is the length which was mentioned in the beginning. I think I already heard that the duration will be longer, but I don't have any details about funding and progress in extending the lifetime.
A quick one, Johannes. When will ESA want to have the finalized and frozen the requirements?
The requirements will some details of the mission are frozen in this month. Some specifications of the satellite, but probably some aspects can be defined a bit later. And yes, and I just see from Peter that the mission lifetime is already at 5 years. Has already been extended to 5 years.
Oh, that was easy. Okay, if there are no other